Natural numbers equation, the sequel. You're here, you've been waiting for it, let's talk. So we're back to this same equation, 7x plus 12y equals 220, but x and y are both natural numbers. Now, we went through a sort of listing them out approach last time, but what if we take a topic from some of the further maths and further pure modules, depending on your exam board, modular arithmetic. Now, what does that mean? Well, we can count, basically when we're talking about whole numbers, this is what's telling me I might want to do this. If I want to count, say, mod 5, my numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We essentially count modular 10. We keep track of how many 10s we get through, but we do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 1, 10 and 0. 11, which is 1, 10 and 1, 1, 10 and 2, 1, 10 and 3. So we go this way. So if I wanted to count these numbers modular 5, it would go 1, 2, 3, 4, 0. 1, 2, 3, 4, 0, 1, 2. You can think of these as the remainder when you divide the number by 5, for example. Okay, so 6 divided by 5 is 1, cool, remainder 1. 7 divided by 5 would have a remainder of 2. 8 divided by 5 would have a remainder of 3, and so on and so forth. 10 divided by 5 would have no remainder. So that is what modular arithmetic does. Okay, and it's a really cool way if we're going in cyclical patterns to keep counts. At some point, I will keep track of where my board erasers are. Okay. All of that to say, why, Nick? Why? Well, if we rearrange this as we have been doing, and we're going to take a slightly different tack. Whereas before I was saying, oh, this is a modular of 4, etc. Well, how about we realize that this is now a multiple of 7. All right, it is 7 times something. So that is equal to 0 in modular 7. Okay, so it is a multiple of 7, and multiples of 7 are 0 modular 7, because if I divide it by 7, I will have no remainder. That's what we mean. Now, what's really cool about this is I can start transforming everything else into modular 7. So 220 is 7 times 31 plus 3. So that means it is equal to, so if I divide 220 by 7, I will get 31, cool, whatever, but I'll get a remainder of 3. So 220 is 3 modular 7. And 12, well, that's 7 times 1 plus 5. That is equal to 5 modular 7. Okay. So what does that tell me? Well, the nice thing is, because again, everything is natural numbers, these all combine in the ways you might think, and you can plug all of this in to make sure that this does work. I can just replace all of these numbers by their values modular 7. So my equation becomes 220 was 3 minus 12 becomes 5, y is equal to 0 mod 7. All right. So this is what we know. So 3 minus 5y is equal to 0 mod 7. So what that tells me is 3 minus 5y is equal to 7k. 7 times something. It just makes everything a little bit nicer. So 3 minus 7k is equal to 5y. Well, actually, no. I'm going to do this slightly differently. Might be slightly nicer to do it this way, because we don't want fractions. We're trying to avoid fractions here, right? So 3 is equal to 5y. To find y, I need to multiply by the inverse of 5. But here's the thing. In modular arithmetic, everything is a whole number. So we cannot do fractions. And that's why I've changed tack here a little bit. So what I want to do is I need to multiply this by something, right? And I need 5 times the something to be 1 in modular 7. Well, 5 times what is 1 modular 7? We could list that out. So we get 5. 5 times 2 is 10, which is 3 modular 7. 5 times 3 is 15. Ooh, which is 1 modulo 7. All right, that's 2 times 7 plus 1. So if I do 5 times 3, in the mod 7 world, 5 times 3 is 1. So that tells me that we are going to multiply both sides by 3. And we're going to see what we get. A little bit of modular arithmetic for us there. Now, 3 times 3 is 9, but 9 modulo 7 is 2, right? 9 divided by 7 is 1, remainder 2, is equal to y in mod 7. So that tells me that y is going to be some multiple of 7 plus 2. Bosh. Y is some multiple of 7 plus 2, which is kind of funky. Right, we need to put that back into here to get something on, because we do need to have an idea of what k needs to be, right? So k, okay. So what do we get from that? Well, don't forget, 7x is 220 minus 12y. All right, so we do need 220 minus 12y to be positive. All right, we do actually need 220 minus 12y to be positive. So let's go back. So at this point, we've got this, and we are pretty set. That is a pretty easy condition to check. And now we need to find our values of x. And I'm a little bit out of space on the board, so we are going to go back. So we get y is 7k plus 2. Now, 7x is 220 minus 12y. Well, that tells me that 7x is 220 minus 12 times 7 is 94k. Minus 24. That's 196 minus 94k. So x is, 10, 20. 20 puts me on 140, so I think that's 28. Which makes sense. Minus 12. Okay. Now this already tells me x is positive, so I know that k has to be 0, 1, or 2. So really, all I have to do is plug those in. So k equals 0. I get x is 28, y is 2, k is 1, x is 16, y is 9, k is 2, we get x is 4, y is 16. And there we go. Much more elegant, making use of that thing that might seem a little bit odd if you're learning it at school, modular arithmetic. It brought us all the way down. Playing around with modular arithmetic brought us all the way down to this bad boy here, which was really funky, I thought. Really, really funky. Hope you enjoyed that. Drop us a comment. How do you feel? How do you feel the two methods compare? Let us know. Subscribe to the channel if you haven't already. Drop us a like and subscribe so you know when more absolute math insanity is coming your way. I'm Nick. See you soon.